Okay, so for my first video, I'm going to be explaining question 6. So a cannonball shot from a cannon is fired at an angle of 37 degrees from the top of a 50-meter cliff. Below the cliff is a level horizontal field. The initial velocity has a magnitude of 50 meters per second. Okay, so for part A, let's draw a picture of the scenario. So here I have my cliff, which is labeled 50 meters. Then the angle which the cannon is being fired at, which is 37, and then the magnitude of the velocity, which is 50 meters, and then this arrow is just a rough curve of the path that the cannon took. So first of all, for part B, I wrote out my vertical and horizontal variables. So the initial velocity for y is 30.9, which I found by solving for the sine of the hypotenuse over the opposite over the hypotenuse when that I plugged in 37 because that's the angle which the problem gives you. Then initial vertical velocity over 50, which is the magnitude of the velocity which the problem gives you. So after I solved for that, I got 30.09 after plugging that into my calculator. So I plugged that in for my initial vertical velocity. Then for my final vertical velocity, I got 9.72, and I got that after solving for that value down here in part C, which I'll go over in a minute. And then for my change in y, I put 50 because the problem gives you that it's 50 meters. Then the acceleration of y is negative 10 because we know that is the value of gravity, and it's negative because it's going down. Then the change in time is we solve for that later, which I'll get to. Then for the horizontal variables, the initial horizontal velocity is 39.93, which I got by solving for cosine over here, which is the adjacent over the hypotenuse, and then I plugged in 37 over 50, and then solving that on my calculator, I got 39.93. And then I put that for the final vertical velocity as well because I know that the acceleration is 0. So I was able to put both of those in there. And then for part C, the question asks you how many seconds does the cannonball stay in the air. So after solving for the final vertical velocity up here, I was able to solve this kinematic equation, and I got 2.03. So the cannonball was in the air for 2.03 seconds. And then for the final question, part D, it's how high above the field is the cannonball at the highest point. So to solve for the max height, I rewrote out my variables and put in my question mark at change in y because you're solving for a different change in y. So I plugged in my same variables there. I didn't solve for change in x because it doesn't really matter in this problem. And then after plugging into this kinematic equation, I got 40.41, which is the max height.